Hey, it's Andrew Voss, and we're starting to go over the three major forces involved in rocket flight, starting with weight, which is the downward force on the rocket due to gravity. You can see here in this infographic that the weight is pulling down on this rocket towards the Earth. It's an attraction between two masses. The rocket has a mass m, and mass is the measure of the amount of matter or stuff the object has, and it's a little bit different than the weight. The mass is accelerated downwards due to gravity. This acceleration due to gravity is equal to g, or the gravitational constant. So on Earth, g is equal to 32 feet per second, or 9.81 meters per second. This is called the gravitational constant, and it's a function of how much mass the Earth has. So if we go back to Newton's second law, the force is equal to the mass times the acceleration. So the weight force is equal to the mass times the gravitational constant. Now, the heaviest rocket of all time was the Saturn V rocket, which was used for the Apollo missions. Built in 1966, it weighed 6.5 million pounds. And you can see the Saturn V here next to the Statue of Liberty. 6.5 million pounds. That's crazy, right? Look how big it is next to all these people here in Huntsville, Alabama. Now, even bigger rockets are being built right now, but they've never been flown. So here's some questions about weight that you can think about before we move on to the next force. What happens to a rocket's weight over the length of the mission? And what are some of the ways that you can reduce the weight of a rocket so that there is less force pulling it back down towards the Earth and it makes it easier for it to get to outer space? So again, what happens to a rocket's weight over the length of a mission? What ways can you reduce the weight of a rocket?